This is the k-means use the picking. The goal of k-means is just to cluster the datasets into a set of clusters. Each observation belongs to a cluster with the nearest mean. And this kind of computation requires recursive iteration. The computation will converge until the cluster centroid do not move. And this is kind of computation require iterative computation, but picking statements do not provide this kind of language support, and this is a common complaint of picking language. It do not provide control flow language, and now the picking has a response for it, the pig embedding API. So picking, now you can write some Python script and embed the picking statements inside of it, and by leveraging all language feature provided by Python, including the control flow, like the if, else, and the while loop. This is very helpful for iterative applications, and because picking statements do not provide this kind of support. By leveraging Python, you can use picking to describe more complex business flow of your applications. So this is one feature of picking technology. And here is the k-means use picking. It basically consists two parts of two code components. The first one is outside loop. This is the loop. This is outside loop. And we compile the pick statements outside of loop because we are going to evaluate the same statements every time within the loop. So we do not need to compile these statements inside a loop. And then we define a complex function named centroid. And this is implemented by Java. The reason we use the Java defined function is because the pick statements do not provide this kind of computation to find the nearest centroid for specific observation. So we have to implement it with Java, and then we define it as a function. After that, we can leverage that function within picking statements. And now we go inside the loop, and inside the loop, we combine the picking statements with the Python variables. The variables is transferred from the Python scripts, and it binds into the pick statements. After that, we will run the compiled pick statements with a run single operation. The run single will start the pick engine and run the pick statements on the Hadoop cluster iteratively. And the run single will not return until the computation is done. This is useful in the k-means because the k-means the current computation of k-means will not start until the previous until it gets the output result of previous iteration. And with inside these code lines, it's basically similar to other implementation of Java, like the Java implementation of k-means, or C implementation of k-means, or Twister implementation of Java implementation of k-means. It's just implemented with the pick statements, so I'm not going to through it. It will basically update the centroid. And here is the user-defined function. The reason why we use the user-defined function is that picking statements has some limitation. And to overcome those kind of limitation, we will leverage the power of user-defined function. And here is the pick embedding technology we already illustrated in previous slides, that you can leverage Python's capability like control flow, if else. And we just go through that in previous slides. Here is the hands-on to run the picking k-means. We will use the sandbox, and we can make some demo. So This is the hands-on package, and this is the peak word count. We will remove this one. And we will go inside a package. Here is the README. Let's look what's inside of it. It's basically set up some third-party classes. And then we will put the input file into HDFS. No, we just, for simplicity, we just copy it from. Then we check whether we already put it there. It's there, the input text. We'll go inside the peak statements. Okay, it will load the data and split each string line of input files, and then filter some unnecessary keywords and group the words and count the number of each word. So we will run it. For safe, we will use the standalone mode first. Word count. It do not touch HDFS this time. It just do the program locally. We get an exception. The output is there. So we remove it, run program again. Okay, it works. Let's look at the result. Part. Okay, here's the result. It's the word count result. Okay, then let us go to the MapReduce mode. It's more practical. We already load the input data to the HDFS in this case. So we'll see what's the difference. So these are different approach to process the input data with peak technology. One is standalone node. It's just for debugging. This mode is more practical. It's on Hadoop cluster. It's 15% is done. We just have small input data sets so that it won't take too much time. Okay, it's done. Let's look what is the output result. Word count. It's no, we need to go through. Here's the output result. So Hadoop has its own format of output results. This is different from the local mode. Okay, so we will have a similar results in HDFS on Hadoop cluster. So this is it's very simple. You can do it yourself as well.